This is chapter number 1, Chemistry of Representative Elements, that is part of Inorganic Chemistry. The topic that we will study today is the industrial preparation of sulfuric acid, which is also known as the oil of vitriol, and it is manufactured industrially by the contact process. The first question, that why should it be prepared? Due to the versatile nature of the sulfuric acid, it has great significance and multiple uses in the industry. I have listed few of these below. It is a widely used reagent in the manufacturing of fertilizers, drugs, paints, and explosives. It is used in the petroleum industry as well as an electrolyte in the storage batteries. Detergent, silk industry, paper and cotton industry also utilize sulfuric acid. It can be used as a stain remover or as a pickling of sealing agent. In laboratories, we use this for the acidic medium. And the most important, that it is used as a dehydrating agent. It means as a dry agent. Now the process. Before I start with the process, I'd first like to explain that why it is known as the oil of vitriol. Since it is extracted through the distillation of the green vitriol, which is the common name of ferrous sulfate, therefore it is known as the oil of vitriol. You get this in your MCQs, that is the multiple choice question answer. 1 mark, that what is the common name of sulfuric acid? So it is the oil of vitriol, and it is extracted through the distillation of the green vitriol, and green vitriol is the common name of the ferrous sulfate, which is a green colored crystalline salt. To understand the manufacturing of the sulfuric acid, we must first understand the steps that it involves. Contact process involves 4 steps. The first one is the oxidation of sulfur. Oxidation of sulfur means that reaction of sulfur with oxygen. Reaction of sulfur with oxygen at an elevated temperature of around 400 to 500 degrees centigrade results in the formation of the sulfur dioxide gas. The second step is the conversion of the sulfur dioxide into sulfur trioxide. This reaction takes place in the presence of the catalyst, which is the vanadium pentaoxide. The temperature is around 400 to 500 degrees centigrade and the pressure is 1 to 2 atmosphere. It is an exothermic reaction, so the heat produced is minus 45 kilocalories per mole. The third step is the absorption of the produced sulfur trioxide onto the sulfuric acids, which results in the formation of oleum, which is also known as the fuming sulfuric acid. The fourth step is the dilution of the oleum, which results in the formation of 98% pure sulfuric acid. The thing to remember here is that you can easily see that for step number 1, 3 and 4, the reaction is irreversible. It means once the product is formed, it cannot be reconverted into reactant. But for step number 2, it is a reversible reaction. So the most common mistake that student makes while attempting this question is that they make the second step also irreversible. First, third and fourth steps are irreversible, single-headed arrow, whereas step number 2 is reversible, a double-headed arrow is used. Now for the pictorial representation, and then I'll also explain the explanation part that you can write along with these steps. Here you can see that in this diagram you have 7 chambers. I have done the labeling as well. The first 4 chambers, that is the pyrite burner, dust filter chamber, washing tower and drying tower. These are all the part of the step number 1. The step 2, which is the conversion of sulfur dioxide into sulfur trioxide, takes place in the contact tower. The third step, absorption of the sulfuric acid on sulfur trioxide, takes place in the absorption towers. and the dilution of oleum takes place in the last tower. For the first tower, as we already know that for the production of sulfuric acid, some reactant or chemical must be used. So the chemical used here is the pyrite. Since it is extracted from the earth, so it must be burned in the presence of air. When it is burned, so high temperature is needed. It means 400 to 500 degrees centigrade temperature was needed. Air is allowed in the system. Air means oxygen. Then it further moves to the dust filter chamber, from where the dust is filtered out. Then it is transported into the washing tower. Washing tower, you wash the product that has been formed after the burning, so the washing is done in the presence of the water. Then it goes to the drying tower. Here you can see that sulfuric acid shower has been done, and its properties I stated that it is a dehydrating agent. It means it will remove the water. In the second step, before the formation of the sulfur dioxide, the sulfur dioxide that is produced in the first step contains some impurities in the form of arsenic, silica or carbon dioxide gas that must be removed, otherwise it will hamper the catalytic activity of the vanadium pentoxide. Vanadium pentoxide is the catalyst, and we know that the function of catalyst is either to improve or decrease the rate of the reaction. In this case, it will improve the rate of the reaction because we need to work with the sulfur trioxide. So this vanadium pentoxide will result in the formation of the sulfur trioxide and lower amount of the sulfur dioxide. Then the sulfur trioxide is further moved into the absorption tower where sulfuric acid shower is done and it results in the formation of the oleum. This oleum is then further moved to the dilution chamber where water shower is done and we obtain sulfuric acid that is 98% pure. So you must remember the four steps, their complete valence equation, the irreversible step number 2 must be mentioned correctly, this diagram, and then you can simply write the explanation in your words. Make sure that the diagram is properly labeled and all the key concepts are delivered. How you will get this in your board examination? You get it in 8 marks descriptive. Describe the manufacturing of the sulfuric acid by the contact process. Show by the equation that it is an oxidizing and dehydrating agent. This equation part also gets along with the explanation part. This equation part I will discuss in the video along with the detailed analysis of all the chemical properties. This is all for today. Thank you.